NASA's James Webb Telescope has uncovered a cosmic revelation: 44 new stars hidden in a galaxy 7 billion light-years away. But how did they come to be? These stars aren't just ordinary. They are ancient red supergiants, burning so brightly that they dwarf our sun. What forces could have created such fiery giants? Is there an unseen power shaping them? Using the marvel of gravitational lensing, this distant galaxy has been magnified, unveiling secrets from the dawn of time. What other mysteries could lie within its twists of light? Each discovery brings us closer to unraveling the universe's greatest enigma. This major achievement for space science was made possible by one of the coolest tricks in the cosmic playbook: gravitational lensing. Imagine looking back in time through a magnifying glass the size of a galaxy. That's basically what happened here. But what they saw beyond that distorted veil of light will change everything we thought we knew about the universe. Now, what's this gravitational lensing thing all about? Picture a massive galaxy cluster sitting between us and the galaxy we want to see. This cluster's gravity bends and twists light from the background galaxy, turning it into stretched-out arcs and loops. Without this cosmic magnifier, spotting individual stars billions of light-years away would be impossible, even for a high-powered telescope like Webb. But thanks to gravitational lensing, the telescope could zoom in on a region dubbed the Dragon Arc. This spot got its name because the distorted light looks like a dragon's body curling through space. Now here's where things get even more interesting. Most of those 44 stars are what astronomers call red supergiants. Think of them as massive ancient stars that burn so bright they make our sun look like a flickering candle. These red supergiants are crucial in the grand scheme of things because they spew out heavy elements when they go kaboom as supernovae. Without stars like these, there wouldn't be stuff like carbon or oxygen, the building blocks of life. Before Webb's big find, only a handful of individual stars had been spotted in distant galaxies. Even Hubble, which had been top dog for decades, only managed to identify about 7 such stars. This new discovery blows those numbers out of the water. It's not just about breaking records. This is a game changer for understanding how stars and galaxies formed when the universe was still in its cosmic cradle. So why does this matter beyond just finding some really old stars? It's all about dark matter. Yep, that mysterious invisible stuff that makes up most of the universe. Dark matter doesn't shine or emit any kind of light, so we can't see it directly. But it does have gravity, and that gravity messes with light. By studying how the Dragon Arc got bent and twisted by the foreground galaxy cluster, scientists can map out where the dark matter is hanging around. In this case, the galaxy cluster acting as the magnifying glass is called Able 370. It's a giant clump of galaxies wrapped in a huge halo of dark matter. And it's not just one big lens. There are also smaller microlenses formed by wandering stars in the cluster. These microlenses boost the magnification even more, turning distant stars into something we can actually study in detail. Now imagine trying to figure out what the universe was like billions of years ago. These stars give astronomers a rare chance to do just that. Back then, galaxies were just starting to take shape, and stars like these red supergiants played a big role in that process. By looking at them, scientists can learn more about how early galaxies grew, how stars formed, and what kind of environments they created. Webb's discovery is like finding a window into the past, offering a front-row seat to the early days of star formation. Each of those 44 stars has a story to tell about the universe's youth, and astronomers are eager to listen. This is only the beginning. With Webb's incredible sensitivity and more gravitational lenses out there waiting to be used, who knows what other cosmic treasures are hiding in plain sight? There's already talk about using the telescope to hunt down more of these magnified stars in other distant galaxies. The idea is to build up a bigger sample size, which would help paint a clearer picture of how the early universe worked. Every new star found adds another piece to the puzzle, helping scientists understand everything from the life cycles of ancient stars to the mysterious forces shaping the cosmos. What's wild is that this whole thing started with light that's been traveling through space for billions of years. Think about that for a second. By the time this light reached Webb's sensors, Earth had gone from being a molten rock to a planet teeming with life. And now, thanks to one seriously advanced piece of space tech, we're able to study stars that existed long before our solar system was even a thing. The Dragon Arc stars aren't just pretty points of light. They're cosmic time capsules holding clues about the universe's earliest moments. Each one is a fiery giant, much bigger and brighter than our sun, burning through its fuel at a breakneck pace. These stars don't live long by cosmic standards, maybe a few million years before they blow up in spectacular fashion. But during their short lives, they shape the galaxies around them, spreading heavy elements far and wide. This discovery also underscores just how powerful Webb's infrared capabilities are. Unlike visible light, infrared can pierce through clouds of dust and gas that would otherwise block our view. That's a big deal when you're trying to study stars in distant galaxies where dust is everywhere. Webb can see through that haze, revealing details that were completely hidden before. With this find, astronomers now have a new tool for studying the universe's early days. The next step is to dig deeper into the data, looking for patterns that could reveal more about how stars formed and evolved back then. They'll be keeping an eye out for any unusual stars, ones that don't fit the typical red supergiant profile. These oddballs could offer new insights into the kinds of stars that populated the early universe. And let's not forget about the potential impact on our understanding of dark matter. Gravitational lensing wouldn't work the way it does without dark matter's extra gravity pulling on the light. By studying how light from these stars was bent and magnified, astronomers can learn more about where dark matter is hiding and how it's distributed. That's a big deal because dark matter remains one of the biggest mysteries in science. All in all, this discovery is a major win for space exploration. It's proof that the James Webb Space Telescope is living up to the hype and then some. This isn't just about finding distant stars, it's about opening up a whole new way of studying the universe. And with more discoveries like this on the horizon, it's clear that Webb is just getting started. NASA's latest find might sound like science fiction, but it's solid science. Thanks to the telescope's powerful optics and a bit of cosmic luck, we're getting a glimpse at stars that have been shining for billions of years. The universe is a vast place, and this discovery is a reminder that there's still so much left to learn. Astronomers aren't just interested in counting stars, they want to know what makes these stars tick. Each red supergiant in the Dragon Arc has unique properties, and studying them could reveal more about how stars like these evolve and eventually explode. When a red supergiant goes supernova, it doesn't just end its life, it creates something new. The explosion scatters elements into space, which can later form new stars, planets, and even life. The 44 stars identified in this galaxy offer a golden opportunity to study stellar evolution up close. With more observations planned, scientists are hopeful that they can unlock more secrets about the cosmos. This isn't just a one-time discovery. It's part of a bigger effort to map out the universe's history and figure out how we got here. What makes this even more exciting is that the stars in the Dragon Arc are at different stages of their life cycles. Some are in their prime, burning brightly, while others are nearing the end, ready to go out in a blaze of glory. By comparing these stars, astronomers can piece together a timeline of stellar evolution, helping to fill in gaps in our understanding of how stars live and die. This discovery also highlights the importance of international collaboration in space science. The James Webb Space Telescope is the result of years of work by scientists and engineers from around the world. Without their combined expertise, discoveries like this wouldn't be possible. What might this new technology reveal next? Let's enter the era of cosmic exploration. Christmas in 2021, a rocket leaves Earth carrying something extraordinary, the James Webb Space Telescope. After a few months of careful adjustments and aligning all its fancy equipment, this groundbreaking observatory finally gets ready for action. Fast forward to July 11, 2022, when its very first image is unveiled, and the next day it officially begins its mission. In less than 2 years, this marvel of technology has completely shaken up what we thought we knew about space. It's uncovered everything from mysterious objects in our solar system to distant galaxies that seem to rewrite the rules of the universe. Now, about those early images from the cutting-edge instrument. They didn't just show us pretty pictures. Oh no, they gave scientists a puzzle that nobody expected. Imagine staring at a stunning photo of distant galaxies and suddenly spotting a bright red dot that seems a bit off. Bright? Sure. Red? Fine. But both bright and red. That's odd. The reason for the redness is something called redshift, which happens because the universe is expanding. As light travels from far-off places, it stretches and shifts toward the red end of the spectrum. Scientists can use this to figure out how far away and how old something is. But brightness? That usually tells you how many stars a galaxy has. So, when this little red dot turned out to be both super far away and crazy bright, it didn't fit with the usual story. A quick analysis spat out mind-boggling numbers, 13 billion light-years away and packed with 100 billion stars. For comparison, that's around the same size as our Milky Way. According to everything scientists thought they knew, a galaxy that big shouldn't exist so soon after the Big Bang. And then, to make things even weirder, more of these impossible galaxies popped up. Researchers started calling them universe breakers because they messed with the entire timeline of how galaxies are supposed to form. These galaxies seem to have come together only a few 100 million years after the universe began, while the current theories say galaxies should take at least a couple billion years to grow that big. What's going on here? Well, there are a few ideas. One theory is that these aren't really massive galaxies, but rather something called quasars. A quasar is basically a supermassive black hole at the center of a galaxy, spewing out so much energy that it can outshine entire galaxies. Another idea involves something called bursty star formation, where a bunch of stars form all at once instead of gradually over time. This could make a galaxy look way brighter than it really is. But even if that explains the brightness, it doesn't fully solve the problem of their huge size. Moving on, let's talk about black holes, those terrifying cosmic vacuum cleaners that swallow anything that gets too close. In April 2023, the Advanced Space Observatory found something jaw-dropping. The oldest known black hole, named Sears 1019. This thing formed about 570 million years after the Big Bang and weighs about 10 million times as much as our Sun. That's smaller than other supermassive black holes out there, but it's way older than any black hole has a right to be. Not long after, another black hole was spotted at the center of a galaxy called GNZ11, dating back 400 million years after the Big Bang. These black holes shouldn't have had enough time to get so massive, according to the usual rules. As the universe unfolds, stranger discoveries await. What lies ahead? So how did they form so fast? One idea is that instead of forming from dead stars collapsing, these black holes might have started as direct collapses of massive clouds of gas. Another possibility involves something called population 3 stars, which are hypothetical stars made entirely of hydrogen and helium, no heavier elements. These stars would burn quickly and end their lives in dramatic explosions, leaving behind black holes that could grow rapidly. There's also a wild theory about primordial black holes, tiny ones that might have formed right after the Big Bang. If that's true, it would rewrite everything we think we know about the early universe. And if you thought things couldn't get stranger, Let's talk about the Orion Nebula, where the space-based observatory spotted something nobody saw coming. 40 pairs of what scientists are calling jumbos. These are objects about the size of Jupiter, floating around in pairs. But they're not quite planets and not quite stars. They're something in between. What makes them even more bizarre is that they're just drifting through space, not orbiting anything. Here's the kicker. Gas physics says something as small as Jupiter can't form by itself out in the middle of nowhere. Planets like Jupiter form as part of a solar system, not on their own. Yet, there they are, these weird jumbo pairs floating freely. Maybe they got kicked out of a solar system somehow, but even that doesn't explain how they ended up in pairs. Getting ejected as a pair from the same system without breaking apart sounds almost impossible, yet this advanced space telescope found 40 such pairs in one region of space. This sophisticated instrument isn't just looking at far-off galaxies and weird space objects, it's also finding surprises much closer to home. While testing some of its instruments by pointing them at the asteroid belt between Mars and Jupiter, it accidentally discovered a tiny asteroid, somewhere between 100 and 200 meters long. This was the smallest asteroid ever seen by this observatory. Normally, spotting something that small would be incredibly hard, but it managed to do it by accident during routine testing. Why does this matter? The asteroid belt is like a fossil record of our solar system. It holds remnants from the early days when everything was still forming. Finding and studying tiny asteroids like this one could teach scientists a lot about how the solar system came to be. The Space Observatory's accidental discovery shows that it could help find many more of these tiny space rocks, possibly filling in gaps in our understanding of solar system history. Speaking of planets, let's not forget about K2-18b, a fascinating exoplanet discovered way back in 2015 by the Kepler Space Telescope. It orbits a red dwarf star about 124 light-years away in the constellation Leo. What makes K2-18b special is that it lies in the so-called habitable zone, where conditions might be right for liquid water to exist. In 2019, scientists detected water vapor in its atmosphere, making it the first exoplanet in a habitable zone to show signs of water. Then, in 2023, the Space Telescope took another look at K2-18b and made a new discovery, dimethyl sulfide, or DMS, a chemical that on Earth is only produced by living organisms like plankton. This doesn't mean there's definitely life on K2-18b, but it's a pretty exciting clue. Of course, there's a catch. The atmosphere appears to have only a tiny amount of water vapor, and we don't even know if the planet has a solid surface. For now, it's still unclear whether K2-18b could really support life, but it's definitely a place worth keeping an eye on. In 2025, the telescope will be diving headfirst into some serious sky watching, aiming to answer some big cosmic questions. Under its Cycle 3 program, running from mid-2024 through mid-2025, this telescope has lined up over 5,500 hours of sky gazing. That's 253 different observation missions, all set to push the limits of what we know about space. A huge chunk of its time will be spent hunting for alien worlds and their possible moons. Scientists have their eyes on this distant gas giant called Kepler-167e, which sits about 1,115 light-years from Earth. They're using the telescope's high-tech near-infrared imager and slitless spectrograph to try and spot moons orbiting it. If they find anything, it could be the first time anyone's ever confirmed the existence of an exomoon, which is pretty wild if you think about it. Then there's the mission to get up close and personal with supermassive black holes. These monsters are found in the hearts of galaxies, and the telescope's job is to look at quasars, those bright beacons from way back when the universe was just getting started. By studying these, astronomers hope to figure out how these gigantic black holes formed and how they affect the galaxies around them. It's kind of like trying to understand how cities grow by studying their busiest intersections. But that's not all. The telescope will be peeking into the universe's distant past, checking out ancient galaxies from around 500 million years post-Big Bang. This is when things were heating up and hydrogen atoms were getting stripped of their electrons in a process called reionization. Figuring out how that happened is key to piecing together the universe's origin story. Closer to home, the telescope has its sights set on Saturn's biggest moon, Titan. With its thick, hazy atmosphere and weird surface covered in lakes of methane, Titan is basically a sci-fi world come to life. The telescope will map out what's going on beneath that smoggy sky and study its atmosphere to see if it could possibly support life, even if it's nothing like what we're used to. Meanwhile, the folks running the show at the Space Telescope Science Institute aren't slowing down. They're already gearing up for the next round, Cycle 4, which kicks off in mid-2025. They're planning to hand out a whopping 8,500 observation hours. Proposals are due by October 16, 2024, so it's a busy time for anyone in the space biz. Could Titan's alien lakes harbor unimaginable life? Will Cycle 4 bring discoveries that redefine science? Comment your theories and subscribe for more mind-bending cosmic updates. Stay curious.